All right, today we're going to study the precise definition of a limit. Now, as this precise definition limit, it's very abstract. It's the most difficult section in this whole book. So I hope you will understand some of that, yeah, I hope you are able to do some exercise after this lesson. Okay. So what's the definition of precise? What is a precise definition limit? So I'm beginning with the two-sided limits. Okay, here's a previous definition. We know that, but it's not very precise. We say that okay, what does it mean? The limit of f of x as x approaches a equals L. Okay, the not precise definition is as follows. This says that f of x approaches L as x approaches a. Okay, but this is not precise in mathematics. Okay, what we really mean is as follows. The next one is called precise definition. Okay, for every number at epsilon greater than 0, there is a number delta such that if x minus a is the difference between x and a is less than delta, and x is not going to be equal to a, so that's why I have greater than 0. Then the difference between the value of f of x and L is smaller than any given epsilon. Okay. Now this is hard to understand the language. All you have to do is for any greater than 0, we try to find a delta which depend on epsilon and the function f. Okay, such that x minus a less than delta implies f of x minus L implies it's less than epsilon. So what you have to do is you want to find a delta so that this is smaller, this simple inequality implies the other inequality. Okay, so those two are not equivalent. Those two inequality, just one inequality implies another inequality. Okay, so the inequality on the left-hand side implies the inequality on the right-hand side. Okay. So I'm beginning with the following problem. I'm going to begin with the following problem. Okay, here's a question. Show that the limit of 3x as x approaches 1 equals 3. Well, that's obvious to me because x is getting close to 1, 3 times x is getting close to 3. Okay, but that's not precise, the proof in mathematics. Yes, you see that the limit is going to be 3. You see it, but that's not accurate. Okay, so but all I need to ask you to do is the following. I have to show the following. Yeah, you have to show the following statement. In other words, you have to show that for any pre-given number, okay, there is a delta, okay, depends on epsilon, such that x minus 1 less than delta guarantee 3x minus 3 less than epsilon. All right, So we have to, the actions given, I just need to find the delta so that the inequality on the left-hand side implies the inequality on the right-hand side. So let's observe this inequality. This is our goal. You want to prove that, right? So but then this is equivalent to, you take 3 out, okay? That requires some basic algebra skill, okay? Now, then you divide both sides by 3, and those two are also equivalent. So it's clear that if absolute over x minus 1 is less than epsilon over 3, you guarantee those two are equivalent, okay? You guarantee the above holds. So if you let delta equals 3 over 2, then, okay, then x minus 1 less than delta implies, okay, implies 3x minus 3 less than epsilon, okay, less than epsilon. All right. So we solved the problem. Oh, that's easy, right? You see that, right? So all you have to do is just find so given epsilon is given arbitrary small number, could be 1 over 1 billion. Okay, but you just need to find such delta, and then this inequality on the left implies inequality on the right, and that's delta depends on the given epsilon. So if you don't want to understand the definition of the limit, precise definition, but just needed to understand what you have to prove. Okay, so let's look at the next problem. Show that the limit as x approaches 2, 2x minus 5 is going to be -1. Okay, that's also, you know, it's obvious to you. The limit is going to be -1 because when you plug 2 for x, you get a -1. Okay, but that's not the proof. You cannot say I see the limit is negative. That's why it's my proof. That's not proof. What I really want you to do is to show the following statement. Show that for any given small positive integer, small positive numbers, okay, you have to say that there is a number, there is a delta, such that x minus 2 less than the absolute of x minus 2 less than delta implies 2x minus 5 minus -1 less than epsilon. Okay. I don't want to see their equivalent, but I just want to say one side implies the other side. So in other words, you have to find the delta for me. Okay, and give the proof why this delta guarantees that in the inequality on the left hand side implies the inequality on the right hand side. All right, so we make some observation. Okay, this is our goal, right? You want to make sure this holds. So let's choose a delta late to guarantee the hold. But when you simplify this inequality, you have to put it back forward. Then you have to simplify to an equivalent inequality. Make this simple as possible. So you get 2x minus 5 plus 1 is minus 4. Okay? Then you continue simplified. So you get, you take 2 out. So those two inequality are equivalent. Then you divide both sides by 2. So clearly, this last inequality is equivalent to the first inequality. Now then you look at what do we want to do. It says that you have to find the delta. The pursuit of x minus 2 less than delta implies the inequality on the right hand side holds. Okay? So clearly we have to take, we can take delta to be epsilon divided by 2. Okay? And this by the above argument, we can say that we see that x minus 2 less than delta, which is equivalent to x minus 2 less than epsilon over 2, right? Then this implies 2x minus 5 minus -1 less than epsilon. Okay. We already did that, right? Because we show those two, the first one and last one, they're equivalent. All right, so that's all about the whole section. Okay. It's easy, right? So let's try another problem. I hope you understand. This is this is what all we have to do. All right, let's look at the exercise on the back side of the book. All right. This is problem number 17. Show that the limit as x approaches -3, 1 minus 4x is going to be 13. Now, why is 13? I know that's going to be 13 because 1 minus 4 times -3 is going to be 13. But that's not the proof. Okay? We have to prove that why this is 17. Actually, we want to prove the following statement. You translate to the following statement. Okay? For any given epsilon greater than 0, I want to find out this delta such that, that's pretty standard language here, such that x minus -3, if this holds, then this inequality implies that inequality. Okay? So how can I do? If you go to Mac, the tutor tells you, simplify the one on the right-hand side. But don't forget that statement at the very beginning. Okay? You have to show this statement. That's what we know what they're doing here. Okay? So you look at this inequality. I'm going to simplify. Right? I'm going to simplify. I'm going to get 1 minus 4x minus 13. Okay? Those two are equivalent. Yeah, put a symbol here. And this will be -4x minus 12. And then you get rid of the negative sign, 4x plus 12. Then you continue, take a 4 out, x plus 2, x plus 3, sorry, x plus 3. So that also is equivalent to this, okay? So you simplify above complicated inequality to this equality, x plus 3. So clearly, then you look at what do we have to prove, okay? So clearly, you can let delta to be epsilon over 4, right? Then you can go back from here all the way to here, okay? From here all the way to here, because if x plus 3 less than delta greater than 0, then you have the above inequality holds, right? Then implies by the above argument, this, yeah. You can say that by the above argument. Okay? When you prove something, it must be in logic. Okay? You make some computation to put aside. Then at the end, when you give a statement for the proof, you have to say that why this is true. Okay? So you say by the above argument. So you put the argument there, then you tell me what delta you can choose. Then you complete the statement. Why x minus -3 less than delta implies the other inequality. Okay. So the next one, show that the limit x approaches 10, here 3 minus 4/5x equals -5. Okay. So why this is going to be, this is true. You can look at that. 3 minus 4/5 times 10 is going to be 3 minus 8. So it's -5. Yes. This should be the limit. If I just ask you to find the limit, that's what you get, -5. And you don't need, okay, you can see that, okay, because I just plug a number. Okay, I got an answer, but you're not required to give a proof. Okay, but here you have to give a proof using the so-called epsilon delta definition. Okay, show that using the epsilon delta definition of a limit. Okay. All right, now how do you do that? Well, step 1, write down the statement what I have to prove. Okay, you have to prove the epsilon delta definition limit is as follows. For any given epsilon, you have to say that there is a delta. Okay, you have to find that such that, okay, such that x minus 10, if it's less than delta, then you get 3 minus 4/5x minus -5 is less than epsilon. All right. So again, we are going to simplify. Yeah, in order to prove that, right? You're going to simplify this inequality. Okay, step by step. 3 minus 4/5x plus 5. Okay, then you get 5 plus 3, 8. Okay, those are the inequality are equivalent. Okay, then because you have to put the back forward arrow symbol. Otherwise, you cannot go back. Okay, your goal is to prove that holds, right? So you simplify this. You multiply both sides by 5. Okay, then you take 4 out. Then divide both sides by 4. Okay, so it's already similar. You get a very simple inequality, which is just x minus 10. This is a 4, and here epsilon. So these two are equivalent. Okay, if one holds, the other one holds. Our goal is to show that if the pursuit x minus 10 less than delta, then the other one holds. All right, so you can't let delta to be if you let delta to be 5 or 4 times epsilon, then this inequality holds for delta, then implies, right? We want to find delta. This implies, it implies 3 minus 4/5x. That's right. Minus -5 less than epsilon, right? So clearly from above argument, we can let delta to be 5/4 epsilon. But what I want to say that, yeah, we may take that, but this is not unique, okay? You can even take smaller. We may also take a smaller delta, not necessarily, okay? If you take, we may also delta to be epsilon, okay? What's the difference between it? They're all correct answers, so the delta is not unique, okay? But what we have here, okay, what they have here is that if, okay, what's the difference, small difference here? If delta equals 5/4 epsilon, then this one is equivalent to okay? Okay, we already proved that, right? Equivalent. Of course, the left one implies the right hand one. But if delta is epsilon, okay, then x minus 10 less than delta implies, not equivalent, implies x minus 10 less than, because delta is epsilon. So epsilon is less than 5/4 epsilon. So that is 2 is equivalent. So this implies that that's equivalent to this. Of course, this implies that, right? So, but conversely, it's not true. The inequality on the right-hand side does not imply the inequality on the left-hand side, because delta is smaller than 5/4 times epsilon. But this choice of delta still works for the proof. So what I want to say that delta is not unique. There is a delta. Okay, even you can choose a smaller one. Okay, so different students get different answers, but usually people take 5/4 times epsilon. Okay. All right. Now, is there any other way you can solve the problem? I think I'm going to choose, there's another way. Okay, another way is when sometimes it's better for more complicated problems. Okay, I want to prove, right? Remember, we want to prove that for any, let's repeat this problem. For any epsilon greater than 0, there is a delta, okay? Such that x minus 10 less than delta implies 3 minus 4/5x minus -5 less than epsilon. So the next method I'm going to show to you is you're not going to learn from Mac, okay? But that is method works for some more complicated function. This called, we're not going to simplify, we're not going to find the equivalent inequality for the one on the right-hand side, okay? What I'm going to do is, I want to determine delta at the end, okay? This is called delta to be determined later, okay? But we assume that you have this already, okay? Then under this assumption, I'm going to simplify. I simplify this expression. I don't know whether this is less than epsilon, but I want to choose delta later so that this is going to be less than epsilon. That's different way to think about, right? So this is going to be, this is going to be 8 minus 4/5x, okay, still the same. I'm going to take x out, you can take a step by step, you can take 4 out, That's 2 minus 105x. Then you can also take a 5 out, and that's 10 minus x. But you can also express as 5 over 4, no, so 4 over 5, x minus 10, right? Okay. What do we know? We assume that absolute x minus 10 is less than delta. So it's less than 4 or 5 delta, right? Under assumption. This is by assumption. Okay, you already know that. But we want to, what do we want? We want to make sure under the assumption this is less than epsilon. Okay, so this is a, so we want to make sure this is less than or equal to epsilon. So if this will be less than or epsilon, if we delta choose to be less than or equal to 5 over 4 epsilon. Okay, any positive delta between these two numbers that works. Okay, so then you can freely choose delta. Then yeah, then we may take any positive number delta as long as it's less than or equal to 5 over 4 epsilon. Okay, then x minus 10 less than delta implies this inequality holds. Okay, just like what we see there. Okay, so let's go back to here. Let's go back to review this part. We want to prove that x minus 10 absolutely less than delta implies the inequality on the right hand side. That's less than epsilon. We want to find such delta. So I don't know what is delta we need. Okay, at the very beginning, I just assume that x minus 10 absolute value less than delta. Okay, then you simplify the expression on the right hand side. We don't know whether it's less than epsilon or not. We don't know. We have to determine the delta later. So after blah 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 simplifying, I got 5 over 4 times absolute value x minus 10. But under assumption, this should be less than delta. Okay, great. So now you get something, nothing to do with x. I want to make sure this is less than epsilon. Then if you carefully choose a delta, and that is guaranteed. So then you say we may take any positive number delta, which is less than or equal to 5 over 4 epsilon, then that works. That means the absolute over x minus 10 less than delta implies the other one. Okay. All right. And why this is good? Because if you want to show that limit as x approaches 2, x squared equals 4, right? You need that. Or approach, let's try and begin with this. Yeah, the limit of x squared as x approaches or equals 0. Well, that's obvious to you, right? It's 0 squared 0. Right? Okay. Step 1, write down what you have to show. You have to show that for any epsilon greater than 0, there is a delta such that x minus 0 less than delta implies x squared minus 0 less than epsilon. I want to prove this. All right, the very first method we began with does not work here. Okay, we cannot just focus on absolute x squared less than epsilon. Simplify. We have to use a second method. We have to assume that absolute x is less than delta. Okay, we do that under this assumption. We take a look at this. I want to make sure this is less than epsilon, but that is going to be absolute x squared, right? Right, absolute x squared less than delta, so it's less than delta then squared. Okay, great. It's nothing to do with x right now. Then I want, this is by assumption. By assumption. Okay. Then I want to make sure this is less than epsilon. So if delta is less than or equal to square epsilon, that works. Okay. Yeah, for this particular problem, maybe the very first method we can still use that to solve the problem, but there are other problems you cannot do. Okay. So let's finish this. So that means we may take delta to be square epsilon. Okay, the above argument implies if delta equals epsilon, then x minus, this implies x squared less than x squared minus 0, okay, is less than epsilon, okay, by above the argument. Yeah, let me give a complete description of this thing. Yeah, x minus 0 less than delta implies x squared minus 0 less than epsilon. Okay. All right, we're done. So this one, you still can use the first method to figure out the delta. Okay, but I choose this method because we're going to see the next problem, which this is the only method that works. All right. Okay, let me think about another problem. All right, so yeah, change a little bit, right? Show that when x approaches 2, x squared equals 4. Okay, let's do this. All right, so now you have to prove the following. Show that for any epsilon greater than 0, okay, there is some delta such that whenever this is a less than delta, then it implies x squared minus 4 less than epsilon. All right. Now, you may try the method you learned from Mac, you know. I know some students show to you, some tutors. Let's try. Let's try. Okay, let's try. Try this method. I'm not sure that works, okay? Try this method is I'm going to simplify this inequality. Begin with that, okay? You want to figure out what is delta. Okay, everybody knows that. This is going to be, okay? Yeah, I see there is still x minus 2 there. Then how to deal with this? Okay. It's, I don't want to see that, right? Eventually, I want to get the inequality just x minus 2 less something is independent. Yeah. I wish to get an inequality less something independent of x, okay? But it's hard. okay? But depend only epsilon only, okay? Yeah, this should be depending on epsilon, but independent of x, right? So this is difficult. We give up. We cannot do that. So I'm going to use the second method. We assume that x minus 2 less than delta greater than 0, okay? But that's good, right? X minus 2 greater than delta. So we look at this assumption, you will get something like that, right? So you can get x less than delta plus 2 greater than negative delta 2, right? So x is between that, okay? So there's a range between them. Now, you can assume the value of delta not too big, okay? There's no restriction on that. So we assume that we're going to choose delta. So we put addition condition, delta less than 1. Doesn't matter, less than 2, less than 3, okay? Assume that. Then the above inequality will be less than 3, greater than 1. So x again between 1 and 3 right now. That's good enough. Okay, I needed to know. All right, then we look at, let's look at x squared minus 4, okay? Our goal is to choose delta so that this is smaller than epsilon, okay? We don't know, you cannot just say less than epsilon because we don't know. Yeah. Okay, so it's going to be x minus 2 absolute x plus 2. But x minus 2, I know it's going to be less than delta. Great. But I still have to get rid of x plus 2 absolute value. What is absolute value x plus 2? Well, you look at this. X is between 1 and 3, so x plus 2 is between 5 and 3. So x is plus 2 is between 5 and 3. So the absolute value of x plus 2 is less than 5, greater than 3. So it's less than 5 delta. Great, that's how do we get rid of x here. All right, so this is here's by assumption. Okay, this is also by the above assumption, but this is by the assumption, here, by this assumption, let's call it star, right? And there is another assumption, star, right? So this is by assumption star. Then this holds by the assumption, additional assumption on delta star, okay? So now, so if you put additional condition, it's less than or equal to epsilon over 5, then that holds. So that is assumption star. So you have a 3 stars here. So on the way to this, how many assumptions you put on the delta? 2. One is delta should be less than or equal to 1. Another one is delta less than or equal to 5. So we can let delta to be the minimum value of 1 and epsilon of 5. Choose a smaller one. Okay? Then delta is less than or equal to 1 and delta is less than or equal to 5 epsilon. Okay? So that implies if x minus 2 less than delta, then you will get x squared minus 4 less than epsilon. Okay, by the above argument. Yeah, let's go back to this problem. Let's review it. Yeah, let's review this part. Okay, so you are going to prove x squared, the limit of x squared as x approaches 2 equals 4. How do you prove that? You have to say, given option, find a delta, there is a delta such that x minus 2 is a difference less than delta, implies x squared minus 4 less than option. All right, so something like a begin with the inequality. This is our target, right? We want to prove under the assumption x minus 2. You want to prove x squared minus 4 less than option. So you try to modify x squared minus 4 less than option. Then you see, yeah, you got this part, right? But it's harder to get rid of x plus 2. So we don't know, right? We don't know the value of x. You cannot just drop it if you don't like. So I decide to use a second method. Okay, I decided to use a second method. Okay, so x, we assume that x minus 2 is absolute, x minus 2 is less than delta. I'm going to determine the delta step by step. So first of all, you look at this assumption, and you find out x is between 2 minus delta and delta plus 2. So if you make delta a little bit smaller, let's say smaller than or equal to 1, then x is between 1 and 3. If x is between 1 and 3, then x plus 2 is between 3 and 5. That's we need that. Then you simplify x squared minus 4. After you simplify, you get absolute of x minus 2, absolute x plus 2. But absolute x minus 2 is less than delta by assumption. But how can I get rid of x plus 2? Well, I know x plus 2 is between 3 and 5. So the maximum value for that is 5. So it's just less than 5. So it's less than 5 delta. It's nothing to do with x right now. It's independent of x. Then you want to make it smaller than epsilon if you can choose delta less than epsilon over 5. But you go back to look at, you have two assumptions on delta. So you have to put together, combine them together. Delta should be minimum of the 1 and the 3 of epsilon of 5. Whenever it's smaller, okay, then you solve the problem. Okay, then the left side inequality on the left hand side implies inequality on the right hand side. Yeah, this type of problems usually will be a bonus problem on the final exam. Okay, the second one. Okay, but the first one without, without given two assumptions on delta, and could be on the test and quizzes. So, but bonus problems are also important. Okay, and don't lose the points that x, here's this another one. Okay, so you prove the limit of 1 of x equals 1/2. All right. So how do you do that? You write on the statement, equivalent statement. Show that for any epsilon greater than 0, there is a delta such that x minus 2 less than delta implies 1 of x minus 1 over 2 less than epsilon. Now, if you focus on the right-hand side and try to modify, simplify, you're not going to solve the problem. You're not able to determine the delta. Okay? And so you cannot use the first method. We only two different ways to prove this statement. The second method is to assume x minus 2 less than delta, blah, 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 then determine the delta later. Okay? The first method is just simplify the inequality on the right-hand side, and to simplify the form x minus 2. less than something. Okay, then you determine the delta. But we are not able to, from here, we are not able to find and simplify inequality. Okay, we are not able to simplify to x minus 2. There is always x there. You cannot get rid of it. So we cannot use that to determine the delta. Okay? Yeah, you cannot. You cannot do something like a 3 epsilon, 4 epsilon. Then you choose delta to be this. Okay? So this is our delta. Okay? We cannot choose a delta like that. Okay. It's hard. So we have to use a second method. So we assume we have to put 2 assumptions on delta. We assume that it's less than delta, greater than 0. Then it implies x minus 2 less than delta, greater than negative delta, then x less than delta plus 2, delta plus 2, greater than that. I need to make sure that x is aware from 0. Because you look at the expression 1 of x, x cannot be 0. So I needed to put assumption if delta is less than 1. If delta is less than 1, it's going to be 1. You still have this, right? So that's our first assumption on delta. So x is between 1 and 3. Okay. So now under this assumption, let's check this. We will get 2 minus x, 2x absolute value. Okay. Okay. So that is going to be x minus 2, 2x, right? I know this is going to be less than delta. It's an assumption. But how can I get rid of x? Well, the smallest possible value for x is going to be 1. Yeah, it's going to be 1. So it's in the denominator. This is equivalent to saying that 1 of x greater than 1/3 less than 1. Okay? So I can continue to release it, right? It's less than 1. So that's all we can get. So this part is greater than 2. So that's why in the denominator it's less than 1, okay? Now, what it should do. So this will be less than equal to epsilon if your delta is less than equal to 2 epsilon. So there will be 2 assumptions here. One is this assumption. When here's another assumption. You have to combine them so that the 1 of x minus 1 over 2, the absolute value is less than epsilon. So we take delta to be the smaller the value of 1 and 2 epsilon. Okay, then x minus 2 less than delta. Okay, first of all, it implies x less than 1, greater than 1, less than 3. More important is this implies, as I said, as just show you, it's less than epsilon. Okay, so that's all I need. Okay, by the above argument. Right, by the above argument. So you got it now? We also can talk about the limit as x infinite limit, okay? There'll be one-sided limit, or right-hand side limit can get a similar definition, okay? And you can also talk about the precise definition when f of x approaches infinity. So here's definition. What is the precise definition when x approaches a? F of x equals infinity. How can make a precise definition for this. Okay, so this is a equivalent to saying that, well, that means f of x is getting larger and larger. So for any, actually, this is what we call the larger number m, okay? There is the delta such that if x less than delta greater than 0, then f of x is greater than m. So for any given number, I can have a number larger than that. Okay? So for any given number, could be 1 million, 1 trillion, right? I can always show that f of x will be larger than this given number when x is close to a. Okay. So here's an exercise. I'm going to show to you how to do that. Okay. So show that the limit as x approaches 0 from either side, 1 over x equals infinity. Then you say, well, that's obvious, right? X squared is getting close to 0, but it's always positive. Then then 1 over x approaches infinity. So how do you prove that? You have to prove the following statement. For any m greater than 0, okay, there is a delta greater than 0 such that x minus 0 less than delta implies 1 over x squared greater than m. Okay, how can I do that? Right, this is what I have to prove. So when x is getting close to delta, 1 of x, okay. I think there are a couple ways to do. One is you just assume that x is less than delta, right? Greater than 0, so x cannot be 0. Maybe I just don't need to give two assumptions on delta. In this case, 1 over x squared, right? And absolute x is less than delta. So this should be equal to 1 over delta squared, greater than 1 delta squared. Okay, right? Clear? Yeah, because this is the same as x squared less than delta squared. But this is the same as x squared less delta squared. This is the same as 1 over x squared greater than 1 over delta squared. Okay? So this will be greater than or equal to m if you choose, what do you have to do? You solve for delta. So if you choose delta to be less than or equal to square root of m, okay? So that's the only assumption you need. Okay, my answer is let delta to be 1 over square m, then x less than delta greater than 0 implies 1 over x greater than m, okay? So we prove that the limit is going to be infinity when x approaches 0. Idea is pretty similar, okay? Yeah, let's do the last problem. Show that the limit as x approaches 2x squared plus 2x minus 7 equals 1. Right? How do you do that? I know 2 squared plus 2 times 2 minus 7 equals 1. That's correct. Okay. So the limit should be 1. So how do you prove that? So you needed to prove two things, the following thing. For any epsilon greater than 0, there is a delta, okay? Such that x minus 2 less than delta greater than 0 implies x squared plus 2x minus 7 minus 1 less than epsilon. Whoa, this is there's x squared there. Okay, how can I do that? I cannot simplify the one on the right-hand side. Okay, so we have to use the second method. We assume that x minus 2 less than delta. I'm going to determine the delta late. Okay, so this number, delta, is to be determined late. Okay. Under this assumption, I'm going to work on this. Okay, I cannot say less than epsilon because we don't know yet. Okay. So that is going to be x squared plus 2x minus 8. Affected, it's x plus 4, x minus 2. Yes. So this is going to be absolute value, right? X minus 2. I know this is less than delta, x minus 2. So it's delta. But how can I deal with x plus 4? It can be very large, maybe. Okay, I have to get rid of that. So we go back to here, x minus 2 less than delta greater than negative delta, right? X less than 2 plus delta, 2 minus delta. Okay, so if delta is smaller than 1, then this implies x less than 3 greater than 1. Okay, that's all we need. Okay, so if you add delta, this is the first assumption on the delta. Then x plus 4 is less than 7 greater than 5. So the absolute value will be less than 7. 7 delta. Okay, that's the first assumption. Second assumption is we want to make sure this is less than epsilon. So if delta is less than epsilon over 7. So those are two assumptions we need, combine them. So in order to guarantee the above expression is less than epsilon on the way to the end, you have two assumptions on delta. So you can let delta to be the minimum value of 1 and epsilon over 7. Okay, then x minus 2 less than delta greater than 0 implies x squared plus 2x minus 1 minus 7 minus 1 is less than epsilon. So we are done. Great. That's all you need. Now, if you don't understand this part, and go over again. Okay, watch the video again. So let's stop here.